Hello, today I am going to discuss about timer off delay in Allen Bradley PLC RSLogix 500 ladder logic programming. So let me open a new file. Okay, just click File, New. Okay, I select this, make sure driver is emulated 500, click OK. So maybe I create a few run here and I insert some instruction. Okay, this time I click the timer, I insert timer off instruction, right? And then I will insert the virtual output coil, and then I copy the virtual switch. Then I copy this one. Okay, so this address is the instead of digital input, I will use the binary. So the binary address should start from B3. B is a binary. 3 is a number or file type number specifically belong to binary. So I will type B3 column. Okay. I will word 0. Then slash bit. You can use any bit. Maybe I use bit 1. Okay. This one I will say energize timer off delay. Okay. So you can, if you don't understand, you can click the binary data file here. Okay, you can see here. This one is a binary column word 0. One word consists of 16 bits. Start from bit 0, bit 1, bit 2 until bit 15. Okay, you can use any bit here. If you want to use more binary, you can click property and then you increase the element here. Then you have more binary to use. Okay. So this timer off delay. Okay, what is timer off delay? Contrast to the timer on delay that we had learned earlier, this timer off delay will have a delay when you switch from on to off. Instead of switch from on to off immediately, it will have some delay before the dump bit can be deactivated. Okay. Okay, for this timer, we need to give an address. So timer, okay, T4 should start from T4. Okay, timer 4 column, okay, followed by number. You can use any number. You can use 0 or 1 or 2 or 3. Maybe this time I will use 2. Okay, it's up to individual. Okay, then the time base, you can use any multiplier here. This time I use 0.01. Then the preset, maybe I will set 1000. Okay, so the timing set point is preset value multiplied by time base value. So 1000 multiplied by 0.01 equal to 10 seconds. Okay, so timer off delay is no different from the ordinary relay, but it has some delay. So for this timer off delay in this case, when you switch the input from on to off, instead of switching it immediately from on to off, it will have a delay of about 10 seconds before the dump bit can be deactivated. So that is to say, initially when you trigger this virtual switch from normally open to close, the virtual power will energize the timer off delay, and both enable bit and dump bit will be activated. Okay, so when you switch this from on to off, meaning from close to open, this will be de-energized. So instead of switching it on from on to off immediately, okay, it will has a delay of 10 seconds. Then only this dump bit will be deactivated. I will show you later. Okay, so this I will use a timer address. So timer for column 2. Alright, column 2. Okay, this one I will use enable bit. Okay, this I will copy the address here and I will use maybe a done bit here. Okay, maybe I create one more run, and then I will copy to here. Okay, this one I'll use timer timing. Okay, this one I copy to here. Okay, maybe this one use digital output column 0/0. This one maybe is a horn. Okay, copy the address to here, copy address to here. Okay, this one I change a bit to 1. Maybe this one is a motor. Okay, this one may change to 2. This one maybe is a agitator. Alright. Okay. Timer timing is almost similar to accumulating value here. So when the accumulating increase, the timer timing also increase. Alright. Okay, let me compile the file to make sure no error. Then I save the file. Maybe save as. Maybe F timer off delay. Alright. Okay, then I click here to go to download it. And then I click here to click run so that it will run the program. Okay, so see what will happen. Once I trigger this bit to on, it will energize the timer off delay. Once it's energized, the enable and done bit will be activated, and both these virtual switch which is linked to enable and done bit will be triggered from normally open to close. Thus, the virtual power will flow through these two runs and energize both digital output 0 and digital output 1. Okay, then I will switch this input to off. That means trigger from close to open. This will be de-energized, and the enable bit will be deactivated, of course, and the dump bit will not deactivated until 10 seconds later. That is to say, after 10 seconds, this dump bit will be deactivated. Let me demo for you. Okay, and as for the timer timing, it's just similar to the accumulating bit here. So when the accumulate increase, these timer timings also will increase. Okay, let's do it now. Okay, see, both also activated and the output also activated here, right? So what happened if I switch this input from on to off? You can see the timer timing will remain activated because the accumulated value is increasing, and the enable bit is deactivated because you de-energize the timer off delay. So once it reach the preset set point, this done bit is deactivated. Do you notice that? And also the timer timing is deactivated. Okay, let me demo one more time. Okay, you see the accumulated value. Once I click the toggle bit, what will happen? It will reset to 0, and both enable and done bit is activated. Okay, the timer timing bit is not activated yet because we have not triggered the input from on to off. Okay, now watch and see what will happen. This will be activated, enable bit will be deactivated, and the done bit will deactivated after it reach 10 seconds. Yes. Okay, that's it. Thanks.